Hey guys, how are you doing today? This is Yifan, and today I'm going to talk about the second laboratory of our EE542 course. So, as you know, we can see in the official documentation, there are a lot of steps and a lot of works we have to do. However, I just briefly introduce the whole laboratory to a series of questions. So firstly, I think we have to know what is Amazon Web Service and how to use Amazon Web Service to do something, like to create a VPC and EC2 in order to launch an instance. And also, we have to use the EC2 VPC and configure some of settings to build a simple network, which includes a router by VivaOS, and a client and a server, which is running Ubuntu. And after we build a simple network, we also need to test the network performance by using a very, very useful tool, which name is IPERF3. And also, I think in this lab we will face a lot of issues and problems, but actually I think that's pretty interesting because we can figure out a lot of problems ourselves. It can help me learn what is AWS and to learn a lot of pretty important and useful knowledge about computer network. Okay, so the first question is, what is AWS? I think AWS is pretty common and pretty popular. It is a cloud computing platform, and it is provided by Amazon. And I think it can help us to use the cloud computing to store some files, and to we can use AWS. We can take advantage of AWS to build our own web service, like create a website or run some of AI projects like the deep learning, machine learning, and so on. And I also would like to talk about what is VPC and EC2. And I think the relationship between VPC and VP2 is a little bit confusing. So I think VPC stands for virtual private cloud. It is not virtual personal computer. Please know that. It is just like an isolated network environment. It is an environment, and we can create some IP range, subnets, and some of security settings inside VPC. And based on a VPC, we can launch an instance of EC2 on the environment of VPC. So the relationship is like a VPC provides the environment for EC2. If we want to run a VM or launch an instance, we have to configure the VPC before running any kind of EC2 instance. Okay, and it is an interesting part. So I'd like to talk about the story between me and cloud. Actually, the first time I built a website is like 14 years ago. It's 2010, and I just used a Chinese cloud service to create a virtual host. What is a virtual host? It's not like VPC EC2. It's a server, but the virtual host is just how to say, it's just like a very simple. It's very simple. I can only upload my static web pages like the HTML, CSS, and JS. I can only upload them to the to my folder, and also I can only use the FTP protocol to maintain my my website. I cannot use any way to connect the server directly, like the SSH. I cannot use them. So I think it's very simple, and actually it is enough for that time for 10 years ago. Yeah, because we just need to build a very simple website. And yeah, you can also see the price was pretty cheap. And yeah, as you know, I just was a pupil, so I could only use the front page to build some of web pages, and I also used the Micromedia Flash 8 to build some very simple video. And my website was for two popular games. If you are a Chinese person, or you are familiar with some of Chinese cultures, you may know these two computer games for children. They are very interesting, so I built a simple website for them. Okay, so let's go back to the main topic. So firstly, we have to create a VPC. It is the first step. Let me also see the official documentation of this lab. So we can see the first step is to create a new VPC in a certain subnet. So we should go to the AWS official website to find this page. Okay. And then we can see I have already logged in, and I can click here to go to the main page of VPC. Okay, and this is the main page of VPC. It's a dashboard, and we can see there are a lot of regions we can select. And in the official documentation, the default region should be US West 2, which is located in the state named Oregon. Oregon. And we can see I have already created my VPC and a lot of EC2 instances in this region. Region. You can see there are a lot of VPCs, subnets, and so on. You can see. And I also have already created something on this region, North California. We can see VPC, subnets, and instances. Running instances. You can see there are a lot of, because I use different regions to test this lab. So I have already used this region, and the North Virginia. So if I would like to do this lab again in order to show how to do this lab step by step, I have to use this region, because this region is currently empty. I think this VPC is like a default VPC. So let me use the Ohio region to show this lab. Okay, let me go to the VPC page, and we can see it is the default VPC. It is not created myself. So I think I can easily delete this one. it is a default one. I don't need to use it, so just delete it. Let me type delete default VPC. Sorry, VPC is okay. Delete. Okay, I've already deleted it, and I think it is a time to create a new VPC for this lab. So firstly, yeah, I should select VPC only, and the IPv4 CIDR should be 10.0.0.0, and yeah, it should be 16 by following the instruction. Okay, and we don't have to configure the IPv6, and yeah, it is default, and I can just click the button to create it. Okay, yeah, I have a new VPC created myself. Okay, and yeah, it is the first step, so let me go to the next step. Oh, okay. Yeah, I have already done the first step to create a new VPC. And for the second step, I have to create 4 subnets. So by following the instruction, yeah, we have to create 4 subnets. Yeah, and the CIDR should be yeah, the first one should be I think the first one should be, yeah, we can just zoom out, you can see 10.0.1.024, and the second one should be 10.0.2.0. This is the third one, and this is the last one. Okay, let me just create them, and we can go to the subnet page. Just refresh it. Okay, there's no any default subnet, so let me create them. Okay, so firstly, let me select the VPC. I only have this VPC, and I can give the first subnet a name. Yeah, so just let me name it subnet 1, and let me see the zone. Let me choose the first one. Yeah, and for the CIDR block, let me choose 10.0.1.0 and 24. Okay, it is the first subnet. Okay, you can see it is here. And also, I need to create the other 3 subnets. Give the name first, subnet 2. And the IPv4 subnet block should be 10.0.2.0.24, which has 256 IP addresses. And I can create new subnets here by clicking the button. By clicking the button, it is convenient. And the third one should be subnet 3, and for the region zone, I can choose this one. Availability zone, yeah. 10.0.3.0 24, and yeah, this is the second one, this is the third one, and this is the fourth one, and the last one. Okay, let me type the subnet block 10.0.4.0.24. Okay, I think that's all. That's all of the creating subnets, and then I can just see all of the subnets. Okay, I think it's fine. Yeah, you can see there are 4 different subnets. Yeah, the block. Okay, and let's go to the third step. In this step, we have to create the internet gateway. And it is pretty crucial because if we do not create it, we cannot access the internet. So we can, I think it is the default. Yeah, okay. So after clicking the fresh button, yeah, the default one. Yeah, okay. So let me just create this one, and the name. And I also need to, yeah, it's pretty simple. Just by clicking the button. Okay, and then I have to attach the gateway to a VPC. Yeah, it is the first step, attach the gateway to the VPC. I only have one VPC, so just select this one and attach it. And then my VPC has the internet gateway. And also, yeah, in the fifth step, we have to modify the root table. It is pretty important, and yeah, let me refresh it. Okay. It is the default root table, and we saw that it only has one row of the root table in the root table. So I think right now I can only use this VPC to visit the local internet. I cannot visit the I can only use, I think at present by this root table I can only visit the destination, which is inside this IP address block. So if I want to access the whole internet, I have to add a new row, and which is 0.0.0.0. So it means I think it means the whole internet, and I have to choose the target. It is an internet gateway. We just created it a few seconds ago. And let me choose the gateway. Okay, that's fine. And yeah. Okay, I think the sixth step is to allocate the elastic IP. Please remember this word if English is not your first language. Elastic IP. Okay, it's here. Okay, so let me, it's pretty simple. Yeah, we just need to create the, we just need to click the button. Okay, and this IP address should be the elastic IP address. We just created it. And then, we can, I think we can associate this IP address to a VPC or a certain internet Ethernet interface. But right now, we don't need to do it. We just need to, I think after we create the first instance, we can do it. Okay. And and in this seventh step, we will solve a question here. The question is about how is Amazon able to convert your public IP and reach your private IP on the interface? I think this question is about, you can see we have the subnets. There are a lot of subnets, my VPC also have a private IPv4 block. So as you know, the AWS will be able to convert to Swift or to map the IP address, my private IP address, to the public IP address, which is also the elastic IP address. Yeah, this is the public one. So how does it work? I think the question should be a very common and a very important technique. The name is NAT. Yeah, so I think converting IP address between public IP and private IP is actually not a simple process. Yeah, it should go past a lot of processes, but NAT is a pretty important one. NAT stands for Network Address Translation, which is able to allow a public IP to convert a lot of private IP address. And the port number plays a very, very important role because NAT uses the port number to map the private IP address to the public IP address. Okay, and let's go to the next step. Okay, in this step, I also need to answer a question first. We can see, and okay, so we have to do some of research about the AWS IAM. So I think it is a very important part because when I try to log in the AWS, I saw there are two login options. The first one is to use my root account to log in. The second one is to use the IAM account to log in. I think IAM is a very powerful service for managing and controlling the sub-users, not the root user. And I think we can take advantage of IAM in order to control my staff members. I can give my staff members a sub-user account, and I can manage. I can just give my staff member just a little bit right to control some of parts, not the whole thing of the AWS. It can also help me improve the security, the level of the security in my project. So it is pretty useful for a team and for a company. Okay, I think then, it is a time to launch an instance, and there are also a lot of steps. Let's just, Okay, so I think now, now we are in the VPC dashboard. So in order to create an instance, we have to go to the EC2 dashboard. So let me just duplicate this web page and go to the EC2 dashboard. Let me enter EC2. Okay. I think launching an instance is not pretty hard, so we can just click this button, launch instance. Okay, and then we can do some of settings before launch. And firstly, we should give the new instance a name. I can just I think the first instance should be a VYOS router. Yeah, we can see here. So let me just give a name. It's a VYOS router. And in this step, we have to choose an OS image. Yeah, and it is the same thing of the Amazon machine image, because we will try to find the OS image in Amazon in the Amazon image market. So let me choose VYOS and let's search it. Okay, we can see there are a lot of results of VYOS, and these two, I think, these two in AWS Marketplace AMS, I think they are like the official version, and we can see it is not free. We have to make payment for it, and also it's not cheap. Yeah, so I don't like these two. I like to try to find the community version. I think they are free. Okay, and then we can see there are a lot of community versions. They are free. We don't need to pay. And yeah, we can just select one. I think anyone should be fine. Let me select the VYOS 1.3.5. Okay, just give it a second. It's a little bit slow. Okay, and then we have already selected this one. And yeah, it is an interesting part to select the instance type. As you know, we are the first year user of AWS, so I think we are able to try to use the free version of the free type of instance, like the T2.micro. I think we are able to use it, but unfortunately, all of the VYOS version, they are not supported the free version. So we have to choose the like the M5 or other version. Yeah, it's not cheap. And also, I have already found a method to create an instance of VYOS inside a free T2.micro instance. I have already found the method, and it was successful. And if you are interested in how to create a free one, you can see another video on my YouTube. You can just try to try. Yeah. And today, I don't want to use a lot of time to do it, so let me just choose a not free type of instance. And okay, in this step, we have to create a key pair, and the name is required. Oh, yeah, I think a key pair is required. So let me just create a new key pair. So we can just we can enter the name. We can choose the name yourself. Let me choose universal key. Yeah. I will use this key in all of the virtual machine, and we should use the RSA as the type of the key pair. And also, if we want to use SSH to log in the remote PC, we can use the PEM for. But if you are a user of PATI, I think the PPK should be useful. So let me use this one to create a key pair. Okay, then we can see there is a file just downloaded, and it is like the key. If we want to log in the remote instance, we have to use this key. So please save this key carefully and do not delete it. Okay, and we can create a security group for the new instance by the default setting. I think select this option is fine, because we can just we can modify the security group, the default security group later, and we can also allow the SSH traffic. Okay, and for the storage, as you know, we are the first year user, so we can use the free storage SSD for totally 13 gigabytes. So I think just choose 4 gigabytes is fine for the VVOS. It is not pretty large. Okay, I think it's a time to launch the instance. Okay, and launching an instance is a little bit slow. It's a little bit slow because there are a lot of things it have to do. So just wait for it. Okay, today is faster. Okay, let's go to the main page of this instance. Oh, we can see, this instance is running. Oh, it's perfect. But the question is about why this instance use this subnet. Actually, I don't want to use the first subnet for the VVOS. I just want to use the first subnet. So if I want to change the subnet, it is impossible because it is pretty crucial. So I have to select the correct subnet for an instance when I create it. So after create this one, I cannot change. So I think the only way to change the subnet is to terminate this one. Oh, sorry, but I don't want to use this use the first subnet. So it's the only way. Unfortunately, I have to do it again. Okay. It is just being terminating. So let me just launch a new instance again. Okay, so this one should be VVOS. It's a router, and let me. Oh, it's too slow. Just wait. Okay. So let me enter the name of the OS in order to select the image. Okay. Let me directly go to the community AMS. Okay. Let me also select the VVOS 1.3.5. Okay, it is loading. Oh, okay, let me choose the m5.large. And for the key pair, I can choose this one. I have this key, which is here. And also, we can create a new security group. But we have to modify this security group later. And this is a storage. It's okay. Oh, the pretty important thing is to choose the subnet. Oh, which is here. Yeah, which is here. And let me just edit this one. So let me create the first one. Yeah, the first subnet, which is in the block 10.0.1.024. In this block, yeah, by following the instruction. Okay, I think now it should be fine. Okay, so let me create this one right now. Sometimes launching an instance is a little bit slow because the subscribing, the step of subscribing the AMI should spend a lot of time. So the only way is to wait for it. Okay, you can see it is now successful. So let me just go back to the main page of the instance to see the new instance. Okay, we can see the old one has been terminated. So the new one, yeah, which is located in the correct IP subnet, the correct subnet, and it has the correct IP address, which is located in the first subnet. Okay, let's go back to the slides. Okay, now we have already launched an instance, and the next step should be configure the network interfaces. And in this part, we have to create a new interface for the router. And let me just also see it's a step 10. Okay, we also need to create a new network adapter or network interface to connect with the subnet 2. Okay, let me just go back to the EC2 settings. Okay, let me find the network interfaces. Okay, we can see there is one network interface, which is about the first instance, the router, and it should be the default network interface of the router. But as we know, we have to create a new network interface for the router. So let me just create one. So it is the description VYOS ETH1. Yeah, ETH stands for Ethernet, and the ETH1 should be the second Ethernet interface, because the first one should be ETH0, and the default one we just saw. I think the name of that one should be ETH0. Okay, let me select the subnet, and by following the instruction, we can see the second interface should be connected to the second subnet. So let me choose the subnet 2, and the private IP address. I can't use the auto assign, but I like to custom it in order to let me remember it easily. Okay, as you know, it is located in the second subnet, so the IP address will will start from 10.0.2.0 this block. So let me choose 10.0.2.30. Yeah, it is up to you. The last the last part of this IP address is up to you, but the first three parts, it is fixed. You cannot change. And I also have to select the security groups. Oh, we can see there are 3 security groups, but I like to delete one of them later. Yeah. So let me just select one. Oh, as you know, I have already created 2 VVAN OS and 2 security groups. So right now, I don't know which one is the first one, which one is the second one. So yeah, so give me a second. Let me just go back to the security groups page to change it. Okay. Oh, I have to go to the instance page first in order to find the certain security group of the old one. Yeah. Let me click the old one, the old VVAN OS instance, and go to. Oh, it's too slow. And then we can click the security tab. And the security group, what is the security group of this instance? Oh, I think we cannot find it because it has been terminated. Maybe. Yeah, so I can only find the new one. But it's okay. If I can find the new VVAN OS instance security group, if I can find the security groups, yeah. Okay, this one is a new one, and 51B is the last 3 digits. So let me just only keep this one and delete the other 2 security groups because I don't need to use these 2 security groups. And what is security groups? I think it's just like a rule. It's just like the firewall in order to protect our virtual machine. Okay, it has been deleted, but why the default one cannot be deleted? Okay, it doesn't matter. Okay, and then I can choose the correct one of the security group, and also I can create the network interface. Okay, and I think this interface is it's a new one I just created. And then the next step is to, it's this one. Yeah. Okay, this one, yeah. Okay, it's a little bit confusing, so let me just name these 2 interfaces. This one is the Ethernet 1 for VVAN OS, and this one, the old one, should be the Ethernet 0 for VVAN OS. And this one, as you know, is the default one, so I don't need to attach this one. So just for the new one, I have to click this button to attach this interface to a certain instance. Okay, so then click the button to finish. Okay, and then let me go back to the instance page and we can find, let me just refresh. Okay, and then we can see this instance has two different private IP address, and it's too slow. Okay, we can see there are two different IP address, and this one is for a default network interface, which is connected with the first subnet, and this one we can see this one is connected with the second subnet, and it is running in the second network interface named V1OS ETH1. Okay, let's go back to the slides and go to the next step. Okay, and then we also have to check the security group and the ACL setting. For the ACL, actually we don't need to modify anything, and the default setting is fine. We don't need to we don't need to change the setting of ACL. However, the security group is pretty crucial because we have to use the ping command to test the connectivity, and the ping will go through will use the ICMP protocol. So we have to open all of the ports for testing. But I'd like to say opening all of the ports is not it's not a safety way. So it's just for testing. Okay, let's go to the security group to modify some of settings of this. Okay. So we can see there are some of default setting of the SSH and the inbound HTTP, and we also need to open all of TCP from all of source, so UDP from our source anywhere. And the pretty important one, do not forget it, is ICMP, IPv4. And also the source should be from anywhere. Okay, it is pretty important, and Okay, and for this one, I like to say, by following the instruction strictly, we need to do this setting before launch an instance. But as you see, I just launched the instance without this setting, like the security group, the network interface. I didn't I didn't configure this setting before launching the instance. So as you see, if I launch an instance without this setting, I can also configure this setting after launching the instance. So I think it's fine. Okay, in the 13th step, we need to learn how to connect an instance. It's an instance. It's not an instance. And by following the instruction, there is an official documentation from Amazon about how to connect the instance. But unfortunately, this link is, let me try it again. I think this link is not valid. Oh, sorry, it's valid, sorry. Okay, so we can see how to connect the instance by using SSH. And also, if we go to the instance page and try to click the connect button, we can also learn there are a lot of ways to connect the instance. Yeah, but I think the pretty useful and pretty simple method is about the SSH. So yeah, before we use SSH to connect the instance, the first thing is to make sure your physical PC has the SSH client. Yeah, for me, as you know, I'm currently using Ubuntu in my physical PC, so I can easily to type the SSH. Okay, and yeah, if you see some of usage of SSH, which means that I have SSH in my physical PC. If you do not have this one, you have to install SSH. If your computer is not a Linux or not a Mac OS, you have to search and learn how to install the SSH in your Windows PC. Okay, and yeah. Okay, and then we need to name the instance and check the setting. Okay, and let me go to the instance page to name the instance. I think it has a name. And let me just check the information to make sure they are definitely correct. It is pretty crucial. Okay, we can see the IP address is correct, and yeah, I think everything should be fine. And then I think the pretty important step is to associate the elastic IP address with the instance. Yeah, and then we can just associate the elastic IP address with an instance or a network interface. Please note that. Yeah, there are two options I can choose. But I think the better way is to associate the IP address to a certain network interface. Why? I think the reason is because I may have a lot of network interface in one instance. So if I only have one network interface, I can just associate this elastic IP with an instance. But I have a lot of interfaces, so I have to choose one. I have to choose a certain interface to associate with the public IP. Okay, so let me go back to the elastic IP page and to select the certain IP address and try to associate this one. Yeah, and then you can see there are two types you can choose. So let me choose the network interface, and let me choose the Ethernet 0. It is the first network interface of this instance, and it should be located in the first subnet. And let me also, yeah, I think I can choose the private IP address, but I don't need to change this one. So yeah, it should be fine. Okay, and then we can see it is successful. And if we go back to the instance page to see the information of this instance, yeah, we can see the public IPv4 address. Yeah, should be this elastic IP address. It is correct, and then we are able to connect with this instance by using SSH because it has the public IP address. Okay, the next step is to try to ping this instance. Why we need to ping? Because we have to make sure we can visit this IP address. Okay, let me just use ping command and the IP address here. Let me copy this one. Okay. Okay, we can see. We can see it is correct, and although there are some of I think it is correct because I can receive the message from this IP address. It's correct. And the next step is to launch. The next step of the official documentation is to launch another instance of Ubuntu, which is the client in our network topology. But I don't need to go to this step right now because I think the better way is to try to use SSH to connect the instance of the router. Okay, so right now let me just try to use SSH to connect the instance. As you know, we don't want to use the password to identify to do the author check. So we have to use the private key to connect with the remote PC. The private key is here, and I can find this one here. So if I want to use a private key to log in a remote PC, we have to use this parameter I, and then we can just drag this private key here in order to get the absolute address, and then we can enter the username of the remote PC. It should be VivaOS because the system is VivaOS. And the last one should be the IP address. Let me just copy it from here. Okay, let me enter yes. Oh, we can see there is an error. Why there is an error? Because the private key has not been protected yet. So in this case, we have to protect the private key firstly. So let me exit and try to use this command, chmod 400, and drag the key here. Okay, and we can see there is a lock, which means that this key has been protected. And in order to let me use this key easily, I don't want to save this key on the download folder. So let me just move this key to a very convenient folder by using the command mv and this address, and just let me move it to this folder. Okay, and if I use ls, we can see the key is located here. It's pretty easy to use this key. So let me just use SSH I and universal key. You can see we don't need to drag it again because it is actually located in this folder. And VivaOS is the username and the IP address 3.14.213.149. Okay, we can see I have already logged in, and this is the VYOS, and I can use tab to see. Okay, it has 8 gigabytes memory, and okay, I think it should be fine. And let me use fconfig to see the information of the network. We can just only see one valid Ethernet interface. Because we have not configured it yet. So I think right now we can just proceed, just go to the next step, and if we need to configure it again, we can go back. Okay, so the next step is to launch an instance of Ubuntu, which is for the client virtual machine. And I chose the Ubuntu server 18.04 LTS as the operation system. And I think you can also choose another system like the 16.04 or the latest version. You can try it, but I just tried this version, and it is running in a better manner. Okay, and let me just do it again to create a new instance, to launch a new instance. Okay, and it should be client. And as you know, I like to choose the Ubuntu 18.04 LTS. And you can see there are a lot of versions of Ubuntu from the community or the certified sources. And I like to choose the community version because it is absolutely free. And I can choose the 16-bit version. Please make sure it should be x86. Do not choose the ARM version. You can see there are a lot of different versions of Ubuntu, and I think this one is correct. It's Ubuntu 18.04. Okay, let me just choose this one. Okay, and for the Ubuntu 18.04, we are able to choose the free tier, the free type of instance, t2.micro. It is perfect. And we also need to select the key pair. Let me select the universal key because I don't want to create a new key for a new instance. And for security purpose, it is not pretty good, but for testing, using the same key for different instances, I think it's okay. And for the security group, I think I can create a new one and change this one. But I think using the old one is also okay. Let me just use this one because I have already configured this one, and the setting in this security group should be correct. And do not forget to select the subnet select the correct subnet. I like to select the first subnet also for the client, but it is up to your it is actually up to your network topology, so it is not required. Okay, so yeah, it's a time to launch this instance. Okay, it is success, and yeah, it is success, and yeah, let me go to the instance page to see the client, to see information of this client. Okay, and we can see there is one private IPv4 address, which means it has one network interface. And also I can create a new network interface for this client. I can go to the interface. Where is the network interface? It's here. It's actually network interfaces. And let me create the new interface for this one. It should be client Ethernet 1. And let me select the subnet. Yeah, let me select the subnet 2. Why? It's up to your topology, and I think it's a time to let me show my topology first. Yeah, you can see it is located in the next slide, but I like to show it first. And this is my network topology, but there are a lot of topology you can choose. This is my topology, and we can see the router is located in the we can see every single instance are located in the how to say we can see everything we can see every instance have every single instance has a network interface which is connected with the subnet 1, because yeah, we can use this interface to connect to the public IP, to the whole internet. And the pretty crucial topology is about how this router worked. It's like the router, in addition to the first Ethernet interface, the ETH0, there are two different network interfaces located in the router, the Ethernet 1 and Ethernet 2, and I have already created the Ethernet 1, which is connected with the subnet 2, and the Ethernet 2 is connected with the subnet 3. And we can see the client also, in addition to the first subnet, it also has it also has a network interface which is connected to the subnet 2 in order to connect the router. And for a server, it is the same case. So we can see it is the topology I chose. So yeah, I think now you can understand why I create the subnet here. Okay, so let me create a subnet. Let me create an instance which is connected to the subnet 2, and it should be the second Ethernet of the client. And the private IP address, I can also use the auto assign, but I like to custom, in order to let me remember it better. 10.0.2.40. And for the security groups, let me also choose this one. And actually, yeah, this security group is like the global universal security group. It's not only for the VMOS, so I can change the name later in order to avoid the confusing. Okay, and then I have already created the new network interface, and I like to give them the name. The name is crucial. Okay, for the description, yeah, I can see the 7CF. This interface, yeah, should have this name. And yeah, the last interface should be the Ethernet 0 of the client. Okay, let me refresh. Okay, and we can see the new interface we just created. This one, the status is available, which means that it has not been it has not been attached to any instance. So we can attach it right now. Attach it to the client, the Ubuntu client, and attach this one. Okay, it is successful, and just go back to the interface page. We can see, it's too slow. Okay, and we can see, it's pretty slow. So just be patient, because my laptop is pretty old. It is actually 13 years old. Okay, and yeah, we can see the client, the Ubuntu, the Ubuntu VM, the client has two private IPv4 address, and the second one, yeah, this one is the second interfaces. We just created it manually. Okay. Yeah, let's go back to the slide. And then I think it's a time to answer the question in the step 18. Let's see the official documentation. Yeah. If you try to change any configuration of your elastic IP mapping network interface, your SSH would go down. So do not do any configuration on this interface. Oh, yeah. So, give me a second. Let me see. If I try to change the setting of the network interface. Why I cannot find the question right now? Where is the question? Okay, so just go past this step. Yeah, I will come back if I find the question. Okay. I don't think there's a question. So maybe something wrong. Or the question just made myself. It is possible because when I done this report, it is midnight. I was pretty tired. Oh, I cannot find the question, but it's not a problem. Yeah. So in step 19, and I have already created the let me see. Okay. In the step 17, I have already created another network interface for the client. And sorry. I saw this question. Okay, sorry. My SSH will go down. And the question is about why the SSH will go down. It's broken if we change the setting of Ethernet 0. So I think it is about the IP address. The public IP address plays an important role when we use SSH to connect. You can see when I try to connect with this instance, you can see I use the public IP address to connect. So I think every single traffic of this SSH connection will go through this IP address. So if I try to change some of settings of this network interface, if I try to change, like to detach this IP address, or to change to modify the IP address, or to do something inside the VMware OS. For instance, if I want to down these ports, down the ETH0, or change the method of getting how to say. Let me give you an instance. Let me give you an example. If I use ifconfig, I can see it is the information of ETH0, and it is the private IP address. If I really want to change the private IP address in my VMware OS, if I want to change this one, like I like to make some configuration to change the IP address to another IP address, I think the SSH will be terminated because I changed this one, and the pipe of the network traffic through the public IP address should be broken. And sometimes we will see an error if we want to change any kind of settings of this interface, like change the IP address, or change the routing table, and so on. So I think it is not a good time to change the setting of this interface. Okay, so for the step 19, we need to launch an instance for the server virtual machine. It is important, and we can I think we can use the launch instance again. So let me give it the name. The name should be server, and for the images, for the OS, I can choose server. Not server. I can choose Ubuntu 18.04 LTS to find the correct AMI. And also there is a very fast way, which is just copy the AMI ID. It is faster because I don't need to search. And in the client, we can see the AMI. Okay, this is the AMI ID. I can copy this one, and I can use this one here. Okay, it's here. I can just select this one. I can select this one to use the same AMI, the same OS image, the disk image. Okay, and then we can also choose the free instance type. It is enough, although it just has 1 GB memory and 1 virtual CPU core. It is enough because it is a Ubuntu server. There's no desktop GUI. And select the key, the universal key. I don't want to create a new key. And please note that I have to change the subnet by following my network topology. But for you, it depends on your network topology. So I really recommend that before you get started, you have to know what is your network topology. Okay, I think, yeah, I can also use the global universal security group. Yeah, I will change the name. Okay, and it's time to launch my instance. Okay, it is actually success. Yeah, and after launching the instance, I also need to provide another network interface for this one. It's pretty crucial. Firstly, let me just name the default one of the server in order to avoid confusion. This one should be ETH0. And let me create the ETH1. Server ETH1. And please note that it is not a name, it is a description. So why there is no a name field? I don't know. Yeah. And let me choose another subnet. I'd like to choose the subnet 3 by following my topology. Let's see my topology again. Okay, which is here. Yeah. The server's Ethernet 1 will connected to the third subnet. Okay, it's correct. And yeah, for the private IP address, I also can use the auto assign, but I don't like to use them. I can, let me see, 10.0.3.40. Yeah, it's up to you. And select the security group, the universal global security group, and to create this one right now. Okay, and then I can give the name. It should be server ETH1. It's a typo. Server ETH1. And let me double check. Maybe something wrong when I create this one. Oh, it's correct. It's correct. Yeah. Yeah, I think they are all correct. But if there is something wrong, I can also modify and repair check and repair them. Okay, so at present, let me just go to the server's instance page to see the information. Oh, sorry, I forgot to associate. Sorry, it's not associate. It's attach the new network interface, the server ETH1 to this instance. So I can also attach it here, networking and attach network interface. Let me attach this one here. Okay, we can see it's correct because the server has two IPv4 address. And for the client, let me double check. Okay, it's correct, and it is absolutely following my custom address. Okay. Yeah. Let me go back to here. Okay, and for the step 20, there is a for step 20, we have to disable the source and destination check of the router of every single interface of the router. Why we have to do it? So it is a question of the documentation, so I have to answer it. Firstly, let me just show how to change this setting. For the instance VMOS router, we can see in the instance setting. Instance setting. It's not instance setting. It's security. No, it's networking. Okay, it's networking. We can see there is a option about change source and destination check. We can see for this instance it has two different interfaces, and please note that the source and destination check is for interface. It's not for the whole instance. So firstly, just wait for it. I don't know why today my laptop is pretty slow. I think it is about the screen recording. It is too slow. Oh no. Let me do it again. Okay, I don't want to wait. So I just said that the source and destination check is for every single interface, not for the whole instance. So we can also go to the network interfaces page to check and change the setting. So we can see there are two VMOS interfaces, and we can just change the source and destination check. Okay, it is easy. Okay, and we can remove this enable sign, which means that it is disabled. Okay. And also I can for this one. Okay, for this one, for another interface of VMOS, I can also change. It's not description. It's actually the source and destination check. We can also disable this check. Okay. So after we have done this work, let's just briefly answer the question why we have to do it. So firstly, let's talk about what is the source and destination check. I think it is a setting applied to a network interface, and when if the check is enabled, the network interface only processes packets that are associated with its own IP address, or how to say. Let me manage my language to say this problem. I think the source and destination check is it's applied to a network interface, but it is for the every single packet, or every single it is for every single packet, and if we enable this check, only the packet including only the packet that the source destination the source address is the how to say it in English. You can read it and give me a second. I think for every single network, every single Ethernet packet, sorry, it's not Ethernet packet. For every single packet, it has the source address and the destination address, and they are IP address rather than MAC address. So it is not Ethernet frame. It is the TCP/IP or UDP/IP or UDP/IP packet. And if we enable the source and destination check, only for the inbounding traffic, only the destination address same to the interface's IP address can be transferred, and for the outbounding traffic, it is the same. Only the source IP address is same to the interface's address can be transferred. So for some of usage, like if we just want to build a website by using the instance, checking the source and destination address, it is useful and it is helpful for your security. However, when we need to let it become disabled right now, because we have to build a router here. For the router, the purpose of the router is to transfer packets. If we want to check the source and destination address and to block some of packet which has the illegal source and destination address, the router cannot work. So it is my answer. You can read it. Yeah, I think my writing is better than my speaking of English. Okay, so let's go to the next step. Yeah, for the next step, and I also need to say something. The official document does not say. It is about the network topology. Today, I have already repeated this word a lot of times because it is pretty crucial. And yeah, so for network topology, I think our classmates have different opinion of the network topology because some of students they think we should connect the router to the internet, but not how to say. So by the way, some of students have different opinion of the network topology. So I saw someone ask a question in Piazza about the specific network topology, and we saw our instructors answer this question, and they said that we can just build our own topology myself, unless it can become a simple network with a router, and the router has 3 different ports. One is toward the client, another one is toward the server. It should be fine. So yeah, so I think this answer is pretty useful, and it gives me a lot of convenience, a lot of confidence to build my topology. So yeah, so I just built 3 very common topology from what I've heard. So the first one, yeah, is built myself, and I chose this one. We can see every single VM is able to connect with the internet, the whole internet, with a public elastic IP address. So it should be 3 elastic IP address, and we can use it to connect we can use the elastic IP address to use SSH to connect the virtual machine directly. And yeah, the three virtual machines can connect with each other by going through the router. So the router is like the hub. It's like the hub, but the hub is not the network hub. It's just like the hub for this network. It can transfer the packet from client to server, or from server to client. And for the second topology, we can see it uses 4 subnets, and the client and server. The client and server share the subnet 4 for the public IP address. And we can see in my topology, these three virtual machine share all of them share the first subnet for the public IP. I think it's fine because it does work. So it does work. So I think this topology is okay. Yeah, and I also think this topology, these two topology are also able to work. Okay, and for the step 21, we have to check the root table in virtual machine and answer some of questions. So firstly, I don't want to proceed. I just want to log in the virtual machine right now. So we can see now I have already logged in the V1OS, and then let me also log in the different virtual machine. There are 2 ways to do it. The first way is to assign to associate the elastic IP address. Like we can give the client and the server their own public IP address, and I can use it to use SSH to connect it directly. But the second way is about I can also only use the router to firstly I should connect with the router, and secondly I should use the router to visit the client and to visit the server to use SSH to connect it. It's not a straight method. It's not the direct method. How to say? Let me use my dictionary to find this word. Oh, sorry, it's too slow. Okay, I don't want to find this word. Okay, no problem. So okay. So if I want to connect the router first, I also have to use SSH. SSH, and the universal key, and Ubuntu. Please note that it is Ubuntu because I like to log in the Ubuntu. Oh, sorry. It should be V1OS first. After logged in the V1OS, I can go to the Ubuntu. Oh, let me see the IP address, the public IP address. 3.14.213.149. It is a way to log in the client and server, but you can also assign the public IP address for the client and server right now. I don't want to assign it because I think it is a little bit useless. Okay, so right now we can use ifconfig to see the information of the interfaces. we can see our VVOS can only find one Ethernet port. So it is a problem. How to deal with this problem? So we have to configure the Ethernet for the VVOS. Okay, so now I have already goes to the configure part. And if you are a freshman of VVOS, you can see the official documentation of VVOS. Yeah, it has some of quick start guideline to help you to use the VVOS, like how to set the internet. Yeah. Okay, so I think right now, let me just see the configuration right now. Show configuration. Please note that if you want to show a configuration, please exit the configure mode. So I entered the exit before show configuration. Okay, we can see the configuration includes the ETH0, not another ETH ports. So yeah, let me use WQ to exit, and then I will configure other Ethernet ports. Oh, I found a problem because, as you know, the VVOS should have three Ethernet ports by following the, you can see ETH0, 1, and 2, but there is only two, ETH0 and ETH1. So I think I have to create the VVOS ETH2 for my router right now. And it should be connected with the subnet 3. Sorry, I forgot this one. Okay, and I like to custom the IP address, and I like to use the global universal security group. Okay, and then it has been created successfully. And let me attach this one to the VMOS, to the router. Okay, just give my laptop a second. Too slow. Pretty slow. I think it should be fine. No, I didn't see. Okay, it's here. Okay. It's ETH2, and it has been already. Oh, it's also available. So let me attach it again. Let me select the correct. Oh. Sorry, I'm pretty emotional. Okay, it has been in use. It's not available. Okay, so I think right now we can just try to configure the Ethernet of the VVOS router. So firstly, let me go to the configuration mode. And then we have to use set interfaces Ethernet 0. Ethernet it's not 0 because the 0 has already exited. So let me type Ethernet 1 for the Ethernet 1 here. Okay, and how to get the IP address of Ethernet 1? I think it has to be static IP address. I don't want to use the DHCP, because it is a router side. So let me use a static IP address, and please make sure it is pretty crucial. The pretty crucial part is coming. So we have to use the private IP address, and it should be located in the interfaces page or the instance page of the VVOS. Do not use a random IP address. So it should be 10.0.2.30 for ETH1. 10.0.2.30. And yeah, do not forget the 24. Okay, if you don't see an error, it should be fine. And then I also need to configure the ETH2. And oh, it's pretty slow. I cannot control it. Okay, for the ETH2, it should be 3.30. Okay, let me enter. Okay, and yeah. Okay, let me use commit to commit this one and to exit. Okay. Oh, has not been saved. Oh, sorry. I'm sorry. Because I have to use save, not exit. So let me go back to the configure mode again and try to save. But I don't know. Yeah, I don't know when I enter the exit, the configuration changes has been dropped or just not been saved. I don't know. So let me use. So let me see. So let me use show configuration to see. Okay, it is valid. Okay, so let me use fconfig to see the network information right now. Okay, we can see all of the Ethernet they are here. Yeah, all of the Ethernet are here, and I like to use. Yeah. Okay, and then we can use the VMOS to connect the different Ubuntu machine. So firstly, we can use ping to ping the IP address of the client, which is 10.0.2.30. Yeah, if you do not know it, you can try to find it in this page. Just give it a second. Okay, if you want to see the client, yeah, we can see the private IPv4 address should be there, and you can use this one. Yeah, why we want to use this one rather than this one in subnet 1? Because as you know, yeah, for my topology, I will block every single traffic between every single traffic from these three virtual machines by going through the subnet 1. So which means that I will block every single traffic go past the subnet 1 in order to let them go past the router. Okay, and yeah, I will use this IP address to ping. Unfortunately, yeah, this one is not reachable. So let me try to ping the server to see the result. Actually, I think it is also unreachable, and the reason I think it is pretty simple. It's just like I have not configured the network settings in these two Ubuntu virtual machines. So I think they are only able to detect the first network interface, the ETH0. So yeah. So if I use the if I use the subnet 1 to connect, like use this one to connect the client, can I ping? Okay, fortunately, yeah, you can see I can ping this one. It is pretty good. And I think I can also use this IP address to use SSH to connect. But there is a problem about, as you know, we have to use our private key to connect. So, but the VROS system, it does not have the private key. The private key is located in my computer. So the first step is to transfer the private key from my computer to the VROS. It is complex, but I have to do it. So it is pretty easy because we can use SCP. It is a protocol. It is like the sister or the brother of SSH. So yeah, I just show, and you can see what I have done. Universal key. Yeah, the first field is the private key of the VROS, and the second field is the file I'd like to transfer. Please note that although they are same file, but they are not the same purpose. Okay, and I will use VROS and the IP address 3.14.213.149. Oh, sorry, I forgot to choose the folder. I think the folder should be home and VROS. Okay, we can see it is successful, and if we come here to use ls we can see the key is now located in the VROS. So we have used the SCP to transfer the file from my physical PC to the remote PC, and then we can use this key to connect with the Ubuntu inside the VROS. It is pretty interesting. And let me use the universal key and use the Ubuntu and the private IP address 10.0.1.97. Okay, it's like a magic. Okay, it is Ubuntu. You can see it's Ubuntu. It's a client, and we use ifconfig to see ifconfig. Okay, it can only detect the first one. How can I let it detect the second one? I think the very simple way is to configure it. I think how to configure the network in Ubuntu 18.04. I think I know how to configure the network in 16.04. It is easy because we just need to configure the interfaces file. But I'm a little bit unfamiliar with the newer version. Yeah, I have done it, but I forgot. So let me just find it. I don't think it's pretty hard. Let me list the etc, and let me also list etc and network in order to find it's not interfaces, but if I like to go to the interfaces, maybe I can find something. Sudo nano etc network and interfaces. Okay, yeah, we can go to the next, the net plan for the current configurations. Okay. Let me go to the net plan. Okay, this YML file is pretty crucial. We can use it to I have to provide the Okay, we can see there is a file about the network setting, and we can just add some of setting here in order to let the let this virtual machine to know the Ethernet 1 and DHCP 4 no. Yeah, so we can just choose false. There's no DHCP, and I just want to use the static IP address like the Lab1, like the part 2 of the Lab1, and I also need to set the address. I'm not sure my setting is absolutely correct because actually I'm not pretty familiar with this part, but I will try. Yeah. Okay, and I think the first for the IP address, I think it should be 10.0.2.40, and is there any failed of these parts or IPv4? Oh, I'm actually not pretty familiar with this part, but it is not a problem because we can just seek help from the internet. How to configure static IP address in Ubuntu 18.04. Oh, yeah, there's no IPv4. Okay, and it is not ED, it's ES. And this is 24. And also, I have to give the gateway. The gateway should be 10.0.2.30. Why it's 30? Because go back to the topology, we can see the router side of the subnet 2 should be 2.30. But the specific IP address is up to you. Okay, and then we also need to configure the DNS. It may not require, because sometimes you may find that if you forget to configure the name servers like the DNS services, it may not pose a huge threat to your network connectivity. Because I think it is because your router help you to do some of name servers resolving. Yeah, I'm not pretty sure, but I think it's like here. The router may help you to solve your DNS Okay, I cannot control it. I think the latency of my network is pretty high. So I think next time I will try to use, oh, there are a lot of space. Okay, the next time I will try to use my, I will try to use the internet cable to connect with my laptop directly, rather than use the wireless. Okay, just wait for it. Okay, I think that's right, and let me just, okay, save this one, and then we can use this command to apply. Okay, if you do not see any error, it means that my configuration is correct. So let me go to ifconfig to see again, and we can see it is the second Ethernet port interfaces, and we can see the IP address is right. It's correct. Okay, and for another, for a server, let me do the same thing. Let me do the same thing. And the first step is to log in to use the universal key to log in the VivaOS. And let me copy the public IP address. Okay, and then we can try to see the ifconfig. Okay, it is a VivaOS ifconfig, and we can use SSH to log in the server. Universal key and Ubuntu at 10.0.1. How many? Let me see. It is the private IP address of the server inside the subnet 1, because right now the server can only detect and use the subnet 1, the first Ethernet port. Okay, it's 240 is a large one. Okay, it's correct. And let me see the ifconfig of the Ubuntu server. Okay, we can see it can only detect one. So let me use the etc. Let me use the same way to let me use the same way to configure the network again. ETH1. We don't need to do the match, but we can do it. Why we don't have to do the match? Because we can see the in the networking, we can see the index of the network, so we don't have to do it. So I think the Ethernet one will map to the index one of the Ethernet interfaces. Okay, the DHCP should be false. And I think the addresses should be 10.0.3.40. It is the private address of the Ethernet 1. And also, I have to choose the gateway 4. The 4 stands for IPv4. The gateway 4, sorry, it's a typo. I forgot to write the 24. And the gateway 4 should be 10.0.3.30. It is the private address of the router in subnet 3. And also, I like to do the name service. Some of people, they don't like to do it. I think it's okay if you do not do it, but there's no warranty. You have to. You have the responsibility. Okay, let me see. There is no any. Okay, it's correct. Yeah, and let me use this command to apply. DHCP. Why? Let me go back here. Oh, the problem is I have to use DHCP4 because in this version, IPv4 is now in use. Sorry, IPv6 is now in use after the Ubuntu 17.10. So I have to every single setting you can see. Yeah, every single setting I have to mark is IPv4 or IPv6. Okay, and let me apply again. Okay, it is correct, and let me use config to double check. Okay, it's correct. And then we can use the routes to see the routing information here. It is a little bit slow, but yeah, we can wait for it. Let me see the routing information, and then we can see there are a lot of routing rules. Just wait for it and go back to the slides. Okay, and for the step 21, yeah, we have to change the routing table of the client of the server VM. Yeah, we have to change this setting, and yeah, and the question is that if we change the if the IP address has been changed, why the SSH will go down, and what can be used in V1 OS VM to start the DH client in V1 OS VM. So I think the second question is like how to let the V1 OS VM use DHCP to obtain its IP address from the EC2. Please note that it is not means that the V1 OS will issue IP address to router to server by DHCP. It is not this meaning. It means that what can be used in V1 OS to get V1 OS IP address from the upper level, like the EC2, like the AWS, like the VPC. Yeah. So there's no need to build the DHCP system between V1 OS and the Ubuntu clients. There's no need, and let me just answer the question here. Yeah. The question, yeah. Why SSH goes down? Because IP address is pretty crucial when we use SSH. If the IP address will be changed or it is not reachable, I think the SSH will be terminated. Yeah, in this case, we may see there is an error here. You can see the server has terminated, or sometimes you can see the broken pipe. I think it's pretty common. You may always see it. So it means that the connection will be disturbed, or the connection is not stable. But if you change the IP address, it must be. If you change the IP address, it must be concluded of the in the connection. Okay, and the second one, yeah, The second question is about what can be used in VMOS VM to start the DH client. So yeah, if we want to if we want to start the DH client in VMOS VM, it is pretty easy. Yeah, I think we only have to see the configuration here. We can see the Ethernet 0 is settled to the mode of the method of how to obtain the IP address of ETH0 is DHCP. So which means that if we start the VMOS, it will try to use DHCP to obtain the IP address from the upper level by using ETH0. So I think it's okay. And for step 22, the documentation told that sometimes the interfaces are not visible. However, I have already finished this part, and for these two Ubuntu VM, we can try to check this. We can try to check this. This. Oh, I think we can try to check this file, but I didn't check this file. I just modified the file, which is etc netplan and 50 and so on. And we can go to this setting file to configure something. But if you are using a very old version of Ubuntu, like the Ubuntu 16.04, you will not find this file because you have to use the you have to use the interfaces file, etc network interfaces, to configure something. And after you configure something, you have to restart your VM immediately. Okay, so for the 22, I have already checked them before. And for the step 23, is to install the iPerf3 and answer questions. Yeah, also questions. The question is about sometimes we may see the VM are not able to contact internet. So yeah, now I don't know. It cannot. It can or it cannot contact internet. So let's just try. Okay. Firstly, we can see the routing table. Yeah, the routing table of the first one, of the routing table of the client and the routing table of the server. I think they are fine. I don't need to change them. Why? Because we can see the default gateway should be the Ethernet 1, should be go through the router. Although we can also see this line, this line which is go through the ETH0. It's like confusing, but it is correct, because please do not forget this field metric. It's like the distance. As you know, every single network, every single router will go through the nearest or the fastest way to go to the next hop. If the first one, if this rule is valid, it will try to go to this rule. It will always go to this rule. But if this rule goes down, if this rule goes down, like we cannot reach this gateway, I think this VM will try to go to this way, in order to connect the internet. So I think it's okay. And for the you can see for the subnet of the first subnet, it will try to go to the Ethernet 0. So I think it is no need to change. We don't have to change this one. Okay, so right now just try to ping 8.8.8 in order to see the internet, the whole internet connectivity. Okay, unfortunately, we cannot reach the outside internet. If we try to install something like the iPerf3, I also think we cannot install because we cannot reach the outside network. So how to fix the problem and what is the reason of this problem? I think it is a pretty common problem because right now, let's go back to the topology. You will see the answer. Right now the client and the server will go through, will connect to the, how to say? As you know, at present I never assign any elastic IP to the client and server because I think it is not required. It is not pretty useful. It is useless. So I didn't give the IP address to the public IP address to the So I think I can just like cover the internet. Okay, and I can see if the client wants to connect to the internet, it must go through the router. The server is same thing. It must go through the router, and right now the client can connect to the router, and the server can also connect with the router. And the router, as you know, the router must be able to connect the internet because we use SSH to connect the router. So this is so from the router to the internet, it is absolutely connectivity. So in this case, if we so what is the problem right now? I think the problem is the router cannot help the client and server to connect the internet right now. Why? So the question is NAT. Because we didn't configure the NAT before. What is NAT? It's network address translation. If the router cannot translate the private IP address to the public IP address, the client and server cannot reach the internet. So it is the reason. So let me just do the NAT setting right now. Okay, and we can see by reading the official documentation of VivaOS. We can see there are a lot of settings we can use in order to configure the NAT. So firstly, let's go to the configuration mode of VivaOS and try to try to do some configuration. Oh, there's no name because the version of VivaOS is different. And secondly, let's change the source address to my source address. It should be 10.0.2.0. It's for the subnet 2. Every single subnet we have to build a NAT rule. And let's choose the translation address mode. It should be masquerade. It is a pretty safe mode to translation the address. Okay, it's successful, and I also need to create a new rule for the subnet 3. Please note that I only use 3 subnets. I never use a subnet 4. Okay, and it is 3.0 and 101. Yeah. So you may have a question. Why the outbound interface always be why the outbound interface is Ethernet 0, because this interface connected to the internet. Okay, and commit and save this. It's too slow. And save this configuration, and then we can exit. Okay, I think right now, let's try to ping the. Okay, you can see it is successful. We can reach the outside internet. So right now, let's try to install the iPerf and iPerf 3. Firstly, before we use the apt to install, we have to use. Oh, it's too slow. We have to use apt to update, or we can also use apt-get. I think it's the same thing, but the apt is the latest one, and we have to update. You can see it downloads a lot of settings. So the question is why we have to use apt update. Why we have to use it? Because because if we do not use the apt update, some of the how to say, I will say the category or the menu. You can just understand the menu of all of the software inside the apt inside the apt repo are located in your local computer. The menu, the category of the software are located in your laptop. So if you want to download something, although the file is remote, you have to download from the server. But the category, is it category? Let me search this word. It may not category. Oh, it's catalog. It's catalog. Sorry. It's catalog. The catalog is located in your PC. So if you do not update, the catalog will be outdated. It is not new. So some of software you will install the outdated version, or the unsupported version, or sometimes you may not find the software. So we have to update it before we try to okay. And you can use apt, and you can also use apt-get. Okay, and then I think it's a time to download. We can use sudo apt-get and iperf and iperf3. Oh, Sorry, I forgot to enter the install. Okay, and let me copy for a server. Oh. The server may not reach the internet right now. Why? Why the server cannot reach the internet? Let me show the configuration. Yeah, I saw the configuration of the Ethernet. They are correct. And let's go to the NAT. The NAT is also looks like okay, but why the server cannot reach the internet? Let me just reboot to find the reason. Okay. And just wait for it a little bit, seconds. From my experience, it's like 30 seconds. Yeah, just wait for it and let me double check. Is there any problem here? The outbound interface and the source address, translation mode. Yeah, I don't think it's a problem, and I can also use ipconfig to see. Yeah, it is correct. Okay, let me try to connect again to the server. Yeah, in the routing table we can see, we can see every single outgoing traffic will go through the Ethernet 1. Okay, and let me use ipconfig to see again. Okay, it is correct. And if I want to ping the outside internet, oh, it is not successful. But if I want to ping 10.10.2. How many? .40? It is not successful. So the problem maybe not located in the NAT. There is another problem here. So let me go to this YML file to try to find the problem. Why? Give me a second. Let me also see in the instance, is there any issues? Oh, it's a debug time. Yeah, there's no problem. if I want to ping the 10.0.1.66, it is the router. Oh, it is successful. And if I want to ping the 3.30, it is the gateway. Oh, it is also correct. But why? Let me see. Let me see here. Yeah. And if I want to use the client to ping 10.10.3.40. Oh, we will also find a problem. But if I want to use the VYOS router to ping 10.0.3.40, yeah, it is successful. So what is the problem? I don't know. Actually, at present, I don't know where is the problem, because I think every single setting is correct. And the routing table is correct. Let me see again. IP route. The IP route will be faster, because if you just enter router, oh, sorry. IP route, oh, it's not router, it's a route. Yeah, if you just enter route, it is pretty slow. Okay, the default is to this port to gateway. Why? It's pretty. Why? There is a problem. Let me try to figure out. Yeah, this is ifconfig, and we can see let me see the security. Oh, let me see the internet network interfaces. Let me see the setting in order to check the status. And also let me see the security groups. You can see I've already opened all of the ports from via TCP, UDP, and ICMP. It is correct. And let me also see give me a second. Yeah, the server has the correct IP address, and it can reach the gateway, but it cannot go through the gateway to reach another PC. So I think the problem may be located in the router. I just guess. And show configuration again. Okay, Ethernet 1, Ethernet 2, NAT, outbound interfaces. All of them are ETH0, and yeah, the source is correct. The 3.0. The translation means it's also correct. Oh, I don't know, but I think in this case, let me just try to reboot all of the remote PC. So reboot the VYOS, and I can also click here to reboot the server and client. let's try to reboot this two, and the VMware OS have already sent the reboot signal by using command line. I assume after reboot we can okay, it is pretty fast. Okay, if I want to use the subnet 2 address to connect the Ubuntu, is that okay? Oh, sorry, we have to wait because these two virtual machines, maybe I think they are just starting. Yeah. Okay, you can see we can use the subnet 2 address to connect this. Okay, so if I want to try to, sorry, it is. It is also the client. It is the client, and it is also the client. Let me exit and try to log in the server. The server is located in 10.0.3.40. Oh, sorry. I'm so emotional. Yeah, I don't want to face this problem. We can see it is good. Yeah, it is good. And if I want to ping outside, it is not successful. It's not successful. And if I want to try to ping 10 dot, so slow. But for the client, let me double check it can reach the outside internet. It is correct. So slow. And I think, yeah, after looking for some problem, I think I can double check the status of these two network interfaces associated with the router. Let me see for this one. Okay, I find the problem. The problem is located here. I forgot to disable the source and destination check for the VPN-OS Ethernet 2. So it is a problem. I forgot to do it, and it is the reason why I cannot. Okay. Okay, it is correct. Then we can visit the outside internet by going through the router. Okay, and yeah, I have already successfully figured out this problem, and yeah, I think right now let's just go to the next step. I spent a lot of time to figure out this problem. Sorry, and thanks for your watching. Okay, and for step 22, we should use. Okay. Sorry, I forgot to install the IPERF3 for the server. Install IPERF. Oh, before it, you have to update. Okay, and then yeah, we have to install. Install the IPERF and the IPERF3. We can use the space to separate them. Okay, just wait for it. Okay, it is successful, and yeah. For the step 24, we can use IPERF3 to test the bandwidth and the throughput. The bandwidth is for the UDP and throughput is for TCP. Okay, and yeah. Firstly, we have to start the server, the IPERF server on server VM, which is here. Oh, I think before start this part, I'd like to show the trace route result of these two Ubuntu machine in order to prove every single traffic will go through the router. So firstly, yeah, I assume there's no trace route on the virtual machine. So let me install. Okay, it is successful. And for this one, let me also install. Okay, so firstly, if I want to use the trace route to see the route from to see the route from the server from the server to the client, I have to type the client's IP address, which is 10.0.2.40. Okay, we will see is the packet will go through the gateway first. The gateway is located in the router, so I can assume that it will go through the router, and the router will transfer the packet to the gateway of the to the gateway of not the gateway. The server will transfer the packet the router will transfer the packet directly from this IP address to the client directly, and then let me also show if I want to use a server to connect the internet, for instance 8.8.8.8, and we can see it will go through the gateway first, the router first. And for the client, it is same. I can also use trace routes to try to connect the server. It's 40. It's same. It will go through the gateway. And if I want to test it, it is correct. And I can also use the TCP dump to double check the packet, how the packet be transferred, but time is limited, so you can just see my results. I have already you can see here. If I run a TCP dump on the VOS, you can see you can see every single ICMP packet will come to every single ICMP packet from the client or from the server will go through the router first, and the router will transfer them to another virtual machine. So it is the Okay, let's just test the step 24 here. Okay, so for the client, for the server, let me use EE542 as and the server has been launched, and it is listening for the client. And then I can use different bandwidth to test. Let me test the let me test the UDP first. IPEE542 UDP, and it is the server IP address. It should be 10.10.3.40. And the bandwidth, let me just choose 1 megabytes. Okay, it is 1 megabytes. Okay, we will see it is the bandwidth of the UDP. Okay, if I try to give it a large bandwidth, let's see what happened. The bandwidth will increase. The bandwidth is increased, but the proportion of the lost datagrams was significantly increased. But when the bandwidth is pretty slow, the lost is pretty. There's no any lost datagrams. So what is the problem? I think if I use the UDP mode to send some of packet, it may not check it may not control the traffic. So if the traffic is pretty heavy, yeah, so no one can arrive to the destination. So what is the in the before just 3 days ago, I tested it and I try to find the limits of the no lost datagram. So what bandwidth there's no lost there's no lost datagram. So I think it's like 5 megabytes. I tested it in the VPC, which is located in the region of North Virginia. Okay, then we can see, the 5 megabytes is like the limit. It's like the no lost datagram limit. I think it depends on a lot of reasons, but yeah. Okay, and what is the maximum? I think it is like 1 gigabytes. Oh, so yeah, I think different region may have different performance. In the North Virginia, it should be 1 gigabytes, but in this region, Ohio, it cannot reach 1 gigabytes. So if I use 0.5 gigabytes, let me see. Oh yeah, we can see it cannot reach the 500 megabytes per second. So I think the maximum in this region, Ohio, is like 400 or almost 400. Yeah. Okay, so for TCP, it is different. Let's try. For TCP, we can just remove the parameter of U. And firstly, let's just only try the 1 megabytes. Okay, and then we can see, there's no any packet. There's no any packet has been retransferred, so it is successful. If we want to, because the TCP can control the traffic in a better manner. So if we try to increase the bandwidth, let's see the throughput. I think TCP is like a magic because for UDP, if the bandwidth is greater than 5 megabytes, there's absolutely, we can see some of lost datagrams. But for TCP, there's no retransfer. It's pretty good. And we can also increase it to 1 gigabytes to try it. Oh, we can see it can reach 1 gigabytes, but for UDP it cannot. And also, sometimes they are a little bit retransfer, because the speed is pretty high. Sometimes, the packet will lost or damaged, and we can also see the sliding window, the size of the sliding window is being increased here. But for sometimes if we saw there are some of retransfer packet, the sliding window, the size of the window will be decreased because it may find some of like congestion. Okay, let me increase the bandwidth. if I would like to try to increase the bandwidth to 2 gigabytes, the throughput will not increased. Okay. But in my opinion, I think the UDP bandwidth, maximum bandwidth, the maximum UDP bandwidth will be greater than the TCP throughput. But I don't know why. Today, we can also see, we can only see the TCP bandwidth is pretty low. It's like 400. I don't know the reason. Let me try again. Oh, we can see sometimes it can more than 500. A little bit. Yeah, but I don't know the reason. Maybe it is about the lost datagram is pretty high. I don't know. But in my previously test, the TCP bandwidth maximum is 1 gigabytes. It's like exactly 1 gigabytes. Yeah, you can see in my test, I just I just increase the bandwidth, 10 and 100 and 1000. You can see that UDP should be 1 gigabytes and the TCP is almost. It is the sender, it's the receiver. And the UDP, if we change it to 2 gigabytes, it will still at 1 gigabytes UDP. But for TCP, it can also reach almost 1 gigabytes, but it cannot reach 1 gigabytes. I assume the reason is about TCP need more bandwidth to do something like the handshaking, and sometimes it will control the traffic when the retransfer and lost packet happened. So it may not reach the exactly 1000, but it's near. It is close to. And if the bandwidth is 2000, you can see there are a lot of retransfer, tons of retransfer packet, and you can see the sender's window is lower than before. You can see. Okay, so it is my answer. Okay, and in the next step 25, I need to add a delay. I need to add a delay to the interface, both client and server VM, but it is not for the router. So let me add the delay here. But I have to change the interface number. It should be ETH1 because every single traffic will go through the ETH1 to the router. Okay. Then we will try again. And now, the delay has been added. Okay, and let's also test the TCP first for the 1 megabytes. As you know, the delay has been added, but the result of 1 gigabytes UDP, there's no any changes here. And in order to prove the delay has been added, let me just ping try to ping any kind of IP address, you will see. Okay, and previously the delay is almost 8 milliseconds, but now it is 108 milliseconds. So I think I firmly believe that the delay has been added successfully. So let me also try a very large bandwidth. It's like 1 gigabytes. Oh, you can see, because the delay is pretty large. Yeah, the loss data is pretty high. So for a sender, it cannot sync the. Yeah, it's pretty high. Just fewer and fewer packets can reach the. Can be arrived to the receiver. So let me just use a little bit slower bandwidth. Okay. It cannot be concluded. Oh, it's still sending. Oh. I cannot control it. Okay. Let me test again. Okay, and let me also open the server, and for the client, I can choose a little bit slower than before. Yeah. Okay. Okay, as you know, the latency is pretty high. It also poses a huge threat to me to control the remote PC because the SSH will also go through the ETH1 interface. Yeah. Okay, it's pretty slow, so I don't want to test again. So just let me test the TCP. Okay, for TCP, let me also from 1 megabytes. Oh, the server is busy. Okay, for TCP, I think it's fine, and I can also try to increase the bandwidth. Okay, and then you can see, although I have already increased the bandwidth to 100 megabytes, the throughput is pretty slow, and it is interesting that we can see the thickness window. The thickness window is pretty high because you can see the test before. Yeah, although the bandwidth is 2 gigabytes, the thickness window is just 200 it's just like 0.2 megabytes, but after adding the latency, we can see the window has been increased dramatically. So yeah, why? Because the RTT between the client and the server has been increased dramatically. Okay, and I have already give my answer. Yeah, and then I will add a random packet loose rule. Okay, so here, yeah, we will run this command both in the server and the client. Oh, what is the problem? QIDC not found. Why? Why it said the QIDC not found? Oh, I know the reason. Because it is not the Ethernet 0. It should be Ethernet 1. Okay. Because I never change any setting towards the Ethernet 0. Okay, then I think it is correct, and let me try to test again. After adding the random packet loose, or the datagram loose. Okay, so yeah, let's try to test the UDP first. Okay, yeah, you can see. Oh, it's pretty slow, but it is pretty slow. Yeah, you can see after adding the random loosed, the random packet loosed. Sometimes the test will not successful. And also we can use the TCP. Yeah, just remove the U. Okay. We can try to test it via TCP. Okay, we can see based on TCP, it is successful, and we can also see the bandwidth is pretty low, because sometimes the number of retransfer is pretty high. So if the TCP detects the retransfer packet, it may think the traffic is pretty heavy, and the traffic jam may maybe happened. So it will try to slow down, and in order to let the packet be able to transfer. But for TCP, yeah, it's just you can see it. How to say? You can see that UDP for the UDP, we can think that UDP is just like it's just like a 30 years ago's computer. It cannot detect anything. But for TCP is pretty clever. It's intelligent. It can detect anything. And I will also try to increase the bandwidth to 1 gigabytes. Okay, and then we can see, although the bandwidth is pretty high, the TCP throughput is also pretty low. Yeah, because the congestion control is play an essential role here. After it detected the retransfer packet, it will slow down. Okay, and for this one, it will delete any kind of setting, and for this one, it will. Okay, let's just delete any kind of setting here. Okay, and let me try this line. Sorry, it's not Ethernet 0. It's actually Ethernet 1. Okay, and for this one, it's also Ethernet 1. Please do not forget to change it. Okay, and then we can try again. So firstly, let me just briefly introduce what is the meaning of this command. I think this command is just like to try to control the maximum bandwidth, and how to say, it's just like a control the maximum bandwidth, and it will control it will keep the maximum rates. It will hold it at almost exactly 100 megabytes per second, and it will use a lot of way to control it. Okay, and I have already settled it, so let me just try. It's too slow. Let's use TCP to try it. Okay, you can see if I use TCP to try it, although the bandwidth is 1 gigabyte, the throughput has been still at almost 100. Why? Because this command, it will curb the maximum speed. However, if we use UDP, let's see what will happen. If we use UDP, I don't know why the UDP, the performance of UDP is pretty bad. It's awful. But it is different. It is different from my previously test. So So let me just show my previously test again. I don't want to test it right now. Sometimes their speed is pretty low. I don't think. I think it may be it is maybe the result it is the result of changing the region, because some of region may have the higher performance of, or some of region has pretty low performance. I don't know. So let me just try to show my previous results. Okay, and after adding a random packet loss, we can see if we test the UDP, we can see the lost datagram has been dramatically increased. And if we test the TCP, we will see the retransferred packet it is also been increased dramatically. And although we select a pretty high bandwidth, the throughput was also pretty low. And in this step, we also need to check the kernel log to find problems. But however, I have already solved the kernel log. Unfortunately, I never find any kind of items about the log, about the network problem, and I also try to figure out this problem. After my research, I think some of kernel logs do not usually record the packet loss, the latency, the TCP. I think the network problem is pretty common. It will happen every single minute, every single second, every single millisecond. So I don't think it is a pretty crucial thing. Should be saved into the kernel log. So it is my opinion of it. And also, yeah, we can see the MTU. This is the VMOS MTU. It is the server. It is a server. It is the server, and it is the client. You can see the MTU is different for the local loop back. The MTU is pretty high. It's like 64K. But for the Ethernet 0, it's special. It's like 9,000. And for the Ethernet 1, Ethernet 2, it's a normal value. It's 1,000. It's 1,500, and I believe 100 and 1,500 is a pretty common value in every single real Ethernet. Yeah, but the 9,001 it is special. I think this MTU is from the it's from the AWS. So AWS issues the special MTU to our VPC, to our router. I think the higher MTU can help us send large frame in order to increase and improve the performance of network. Okay, so for step 28, we have to delete the testing, all of the previous testing configuration, and then we can use this command to curb the rates. And I have already tested in my previous VPC, which is located in North Virginia and North California and the Oregon, yeah. And I got the same answer, the same result. So yeah, after running this command to curb the rate, if we perform the UDP test, we have found the bandwidth was not affected by the configuration, and the packet loss rate was significantly higher than before. And it is interesting that, I also found a very interesting point. It is about, as you know, in this test, in my previous test, the UDP maximum bandwidth was 1 gigabyte. Sorry, it's not gigabytes, it's gigabits. Sorry, it's my fault. And let's see it again. And okay, let's see it again. And then I think we can use the traffic control to limit to curb the maximum rate. But it is interesting that if I use UDP to control it, if I use UDP to test it, the maximum bandwidth we are greater than 1 gigabytes. It should be, it can reach up to 9 gigabytes. It's pretty interesting. And for a TCV test, it will exactly be curved at almost 100 gigabits. 100 megabits. Okay, so it is my answer, and I think if we want to try to change the maximum, it's not maximum. If we want to change the speed of the Ethernet port, you will see an error here. So I have already answered here. You can just read it. I think the reason is about the AWS Amazon does not allow us to change it because it's pretty complex. It is almost a dynamic speed. So and also I have already configured the configuration on the router, ETH1 and ETH2, and you can see the bit rate is pretty high. It's pretty high. So what is the reason? Although we use different IP address, the different IP address are located in the same PC, the same VM. So it's also like a local how to say? It's like a local loop back. So the speed was pretty high. And if we want to curb the speed or add some latency or add the random packet loss, you may find it is not valid. It is not valid because it is the loop, the local loop back. Okay, so it is the answer, because it will go through the loop, the local loop back, and this above configuration does not take effects. Okay, so this is the last step to make a lab report. I think I have already made a very detailed report here. Okay, so I think that's all. That's all of the lab 2, and you can see the time is almost 11:30, and it's a time to let me submit it. Okay, thank you so much for your watching. It's a pretty long video, and as you know, my English it's a little bit hard to do some presentation, but I think I'm proud. I'm proudly to show my work. So I think my English will be improved if I want to practice it every single day. Okay, thank you so much. Have a nice day.